8 different states of the country. So with this, I would like to introduce a distinguished personality of the first session of the 6th day. We have come to the last day of this FDP, and your active participation in all the 5 days is more appreciable. With this short welcoming, I now would like to introduce our speaker of the session 1, Dr. P. Chandrasekhar Garu. Dr. P. Chandrasekhar Garu, a technical director, project management consultant, technical advisor to Ramoji Film City, 7S Technologies. Dr. Chandrasekhar Garu pursued his degrees MBA through IGNOU University, MS from UK. His specialization industrial engineering and robotics. He is associated with many research groups. Is very much curious about the research. Associated with computer industry in 1978. This is JNTUK mainframe computers. Is associated with the mainframe computers. As associate director at MS Color Kinetics in London, I. Associate director at MS Color Kinetics, Madame Wax Museum. It is his exposure in abroad. Not only the abroad, he is very much curious delivering his services to the parent country, our India. He has contributed a lot to the society. I would like to now very curious to study in front of you. Robotic hand designed and delivered to Bark in 1978. Earthquake monitoring system 1985 in Roorkee University. He has designed and developed this and delivered to the society. Control systems for space simulation chamber delivered to the ISRO. Control system for high vacuum, high temperature furnace delivered to, he worked with the DMRL. Motorized wheelchair, foldable stretcher, and robotic platform for the defense application. Artificial arm for amputee hand personnel. Corner shot gun for defense application. So video guided automatic brush for dental application developed in Australia. So very good, sir. Your contribution is encouraging us a lot. And also he guided project for the PG projects, MBA, MSc project. He has also guided engineering students in the robotics, instrumentation, and artificial, what is called automated systems. I would like to read. He is a winner of 25 gold medals in his career, 17 silver medals, 3 times Prime Minister Award for the science and technology, for his contribution for the science and technology towards the country called India. I would like to now read during the career. Robotic hand is one of the awardee, 3 times Prime Minister Award. Also Space Simulation Chamber, one of the second award. Earthquake monitoring system, another award, consequently from Srimati Indira Gandhi, Shri Rajiv Gandhi, and PV Narasimha Rao, PM of the country. Presented 90 papers on automation and conducted 1,500 seminars on robotics and automation. So now currently he is working on world largest clock, waterfall, Glow Garden Artificial Aquarium, member of Indian Society of Lighting Engineering, International Lighting Designer, and International Market Research Association, member of AVIXA. Audio, Visual and Integrated Experience Association. Sir, we were much delighted to have you here and educate us, empower us, and expose us to with your vast experience, sir. With this, I conclude and I introduce you to these participants. Thank you, sir. Thank you very much. The session is
Uh,
yours.
Good afternoon to all faculty members. It is a pleasure to talk to the faculty. In fact, today I'm able to talk to you just because of my teacher. So the lecturers plays a vital role in students in molding the students. So I wish that all the lecturers who are attending definitely mold better students to make them better citizens of our country, right? So I have taken a topic. It is basically related to electrical vehicles. Now everybody talks of electrical vehicles. Way back in 10 years back, we want to do for the defense unmanned vehicles. The moment unmanned vehicles means it has to be a battery operated. For that reason, we developed a battery operated vehicle. But of course, now you get different types of batteries. Earlier, only lead acid batteries were there. So the base itself we made with the lead acid batteries. That means our own lead acid battery, the plastic base. We have taken a tank, and with that we develop a battery that become the base. Over that we build the mobility system, right? So
You can
here,
share your screen, sir.
my journey in the industry, it is almost 50 years. I'm in the industry. I'm celebrating 50 years. So my experience, what I would like to share before even starting my PPT, mechanical engineers, electrical engineers, electronic engineers, everybody want to shift to IT industry. But I have seen many students, those who are shifted to IT industry, they were not satisfied. Okay, just because the parent peer pressure, they got into IT industry, they are doing the jobs. But they are not very happy. Because 4 years they learned the screws, mechanics, gears, and all these things. Finally, what they are doing, they really don't know. They said, sir, after 4 years, today again we are undo and doing the redoing the new subjects. That means still we are learning. Whereas the other student, those who come from the direct from the computer software, they are doing better, we thought, but we are able to do much better than them. That means we are better engineers than CSC people. And here, one thing I would like to mention, I maybe it out of the way, since the many people are not accepting the core industry, particularly now electrical vehicles are huge. By 2030, our country, we are expecting to put 30% of the vehicle registration by electrical vehicles. So there is a huge scope for electrical, mechanical, electronic people rather than CSC people within our own country, within our own place. Suppose you are staying in a class A city, class B city, class C city, irrespective of that, you are going to get jobs for this. So all the engineers, my faculty, my sincere request that develop all the students to +1 technology. Suppose I am a mechanical engineer, teach them, okay, definitely I know you have a schedule for classes and all this thing. Irrespective of that, all Saturdays, please pair them for +1 technology. I'm a mechanical engineer. Let them teach on Saturday, irrespective, no marking. Don't say this will be credit based on that. I will not get into those things. Saturday, please pair them and teach them +1 technology. Mechanical engineers should be able to learn little bit of electronics, not into details, at least understand the EV core technologies, right? Similarly, electronic engineers should be able to learn a little bit of mechanical engineer about the mechatronics of the EV engineering. Similarly, computer engineers also should be able to, let's say, when I say I'm going to apply AI for battery charging, when he does not know what is voltage, what is the current, what is the wattage, how he is going to apply AI technology. So definitely EV technology is going to work out very well. It has its own drawbacks, but still we are going to push through electrical vehicles. So with that, I'll start my presentation. Please start my presentation. Start the PPT, sir. Deepak sir, are you starting the PPT? Hello?
Sir, I am starting.
Yeah.
Yes, sir.
Not seen on the screen?
Sir, is it visible, sir?
Yeah. Start the
So
presentation.
I'll put it in a presentation mode, sir.
Yeah.
Yes, sir. You can go ahead, sir.
No, it is not come to presentation mode. It's still showing the. Start the slideshow.
It's in my system. It is in presentation mode, sir.
Okay, no, but only it is showing the small screen.
Faculty, can you see the screen?
Sir, but it is not in presenter mode, sir. Not in slideshow mode.
Full screen, sir. Full screen.
Full screen is not visible.
Let's go for full screen, means it is visible for all of us.
Okay.
No, sir.
The size is around 53% only, sir. We can
Yes, sir.
increase. Yes.
Yeah, it is okay, sir. It is okay. It is okay.
No, okay. Even that also.
Yes, click on the slideshow, sir. Yes, sir.
Slideshow.
Yes, sir. Slideshow only. Slideshow only, sir.
No, slideshow means it will not show the slide
Visible.
videos, actually. It is not in slideshow mode.
Slideshow mode only, sir. This one. So this is the regular mode, and this is the slideshow mode.
No, it's same thing it is showing here.
Sir, go back and come again, sir.
Okay. Let me.
Maybe network issue, sir.
Mhm.
Now go for full presentation mode, sir. Yes.
Yes. This is the
Delete
full.
షేరింగ్ ఇచ్చిన తర్వాత ఫోల్డర్లోకి వెళ్ళి ఓపెన్ చేయండి సార్. మొత్తం క్లోజ్ చేసేసి మీ షేరింగ్ ఇచ్చి అప్పుడు ఫోల్డర్ ఓపెన్ చేయండి పీపీటీ మోడ్కి వెళ్తే.
It's okay, sir. However, it is okay. No problem.
Sir, is it clear, sir? Otherwise, you can share on from your own screen, sir.
I'll
stop.
Let me check it out.
Okay, sir. I'll stop it. You share, sir.
Yeah. Let me. You all can see the screen, please.
Sir, we could see the screen, sir.
Okay, let me.
So it is a bigger screen. You can put it in a slide. Yes, sir. Slideshow.
Yes, we can see now.
Yes, sir. Yes, sir.
Okay,
We can see it, but put it in a slideshow mode, sir. Slideshow mode.
Mode only now. You can see now full screen.
Participant, if you have any visibility problems.
It's okay,
It is
sir.
not in.
It's okay, sir.
It's okay, sir. It's fine. We can go to the.
Yes, sir. You can proceed, sir.
No, full screen we are not able to.
But we are not getting full screen, sir. Slideshow,
Visible, no problem.
it is 53%, sir.
Okay, I don't know. 1 second.
Yeah, like beside that 53%, there is some icon, no, sir. So click on that icon. So it will go to the side. So
That's what.
And then slideshow, sir.
Now it's showing full.
Slideshow is not showing, sir.
That's why I don't know why.
The command is F5. F5 is the command.
F5, sir. Command is F5. Function key 5.
Yes. Now it's
No, to get on screen, share screen.
Yes, sir. Share screen.
Share screen. Okay. Now we select. Share screen.
Dilip.
Sir, first open the PPT, sir.
Okay.
Dilip.
And after that to share the.
Yeah, that's what I'm trying to do.
Dilip.
Sir, I'm sharing. Okay, sir.
You try.
I'm sharing, but saris are getting problems, sir.
No,
But
no, okay. Is that
Okay.
clear, sir?
Okay, sir. Make it full screen, sir.
You are seeing the screen.
Now go to the slideshow mode, sir. Slideshow.
काम तो हम लोग ही कर रहे हैं, ऐसा लग रहा है। आप लॉगबुक भर नहीं रहे हो।
Now you see?
क्या काम है ये ला नहीं रहा कब से आंसर की देखे गए बैंक आंसर की है ही नहीं सर। है बनाई हमने बनाई हुई पेपर चेंज करके है मैंने। ओ भाई
Hello.
वो मत करो, वो प्रिंट निकाल रहा है तो प्रिंट मत निकालो।
Hello.
Sir, you can proceed, sir. No problem.
Okay.
It is visible.
When it comes to energy efficient electrical vehicle, charging issues, what are they generally? When you see the electrical motors, okay, the main thing is electrical motor, then power inverter, then power converter, battery charger, charging port. These are the basic system as compared to any combustion engines. When I talk to what do you call as energy efficient? Electrical vehicles powered by the electrical motor using the energy stored in the rechargeable batteries. That's why they are called electrical vehicles. Importance of energy efficiency in EVs: reduce energy waste, enhances the vehicle range, and lower overall operation cost. That's the important, very important. That's why we are going for the electrical vehicles. Global trend and market: EV adoption has increased significantly with over 14 million EV vehicles sold worldwide in 2023. Connection to sustainability and reducing carbon footprint. EVs help reduce greenhouse gas emission, contribute to the climate change and mitigation. And now everybody talks of the climate change, and everybody want to have it to get into greener mode. That's the electrical vehicle contribute to the greener environment. Benefits of energy efficient electrical vehicles. Now, when we say electrical vehicles has a beneficial, then why do we are asking for the benefits of energy efficient? Now the question comes is, suppose I use the non-standard batteries. Every year we replace the batteries, then again it is polluting our environment. Similarly, you use non-standard motors or parts. Then once again you say the normal the combustion engines we use almost for 15 years like that. So we expect that electrical vehicles also to last such long, right? That's why they are called energy efficient overall. Reduction in greenhouse gas emission: EVs produce zero tailpiece emissions, lowering the operation cost, electricity cost lower than the fuel cost, and EVs require less maintenance. This is the most important point. Electrical vehicle, you don't have to every time maintain or change the oil or change the any of the systems actually, right? And it is not the comparatively IC engines. IC engines, every part in the engine is pressurized. That means in any changes, there is chance of leakage and efficiency goes down. Whereas here, it is totally, there is no pressure involved except the voltage and current. Energy security. Reduce depends on the imported fossil fuels, enhance the energy independence. That means whenever we want gasoline or petrol or diesel, we are depending on the foreign countries. That means with electricity, we don't have to depend on those. Enhancing the driving experience, instant torque, smooth acceleration, and quieter operation. Electrical vehicles, suppose you are driving the older car like Ambassador here, and suddenly shift out to electrical cars, it's very difficult to drive because you just press the button, it picks up the speed and torque is given. Whereas IC engine, you have to change the gear, apply pressure, all those things are reduced. Segment-wise sales in 2024. Electrical two-wheeler, we call it by a short name E2W, approximately 1.2 million units sold, accounting for nearly 60% of the total EV sales.
Sir, sorry to disturb you. Are you changing the slides, sir?
Yeah, not coming.
Not coming, sir.
Oh, okay. Then now we can see it at least. Next slide.
Okay, sir. Can you increase the size of the slide, sir?
Yeah, okay. I just
size.
You can?
Okay, sir. Okay, sir. Enough, sir.
Okay.
Okay, proceed. Yes, sir. Proceed, sir. Thank you, sir.
Oh, what happened?
Yes, sir. It's looking good, sir. No problem. You can proceed, sir.
Seeing the slides. That's why I'm just trying.
Yes, sir.
You are able to see the slides, sir?
Able to see it, sir. It is just good, sir.
But why I'm not able to see? One second. You are able to see, sir?
Yes, sir. Yes, sir. We are able to see, sir.
Thank you, sir.
No problem.
Okay.
So come to the first slide, sir. Yes, sir.
Second
Click on
slide?
it, sir.
Second.
Okay, sir.
Right. Thank you. The electrical three-wheelers, EV3W, around 6,94,466 units sold, representing 34.7% of total electrical wheel sales. Electrical cars, approximately, you can say 1 lakh sold, making around 5% of the total EV sales. Electrical buses, only 3,834 units sold, indicating the substantial growth in the public transport electrification. Government targets electrical vehicles in 2030. The Indian government aims to increase EV sales to 30% of the total vehicle sales by 2030, supported by the stricter emission norms and various incentives. If you see the Delhi, you can see notice the pollution level. Now Delhi almost, as on today, 45% of the vehicle they have switched to electrical vehicles. So the government aims to buses 100%, commercial vehicles 70%, private cabs 30 to 70%, two-wheelers and three-wheelers to up to 80%. This is target for 2030. So that means you can imagine the opportunities for the electrical engineers, mechanical engineer, electronic engineer. There are huge opportunities in the EV vehicle field. I request that all the faculty to tie up with any of the electrical EV vehicle manufacturers and separate small course. If you can develop, it will be wonderful, and we will be doing a great service to the student community. Now, government policies, they have changed. Key highlights of the Indian EV policies: NEMA 2013, National Electrical Mobility Mission Plan, provides a roadmap for electrical vehicle adoption and manufacturing, targeting fuel security, Indian rupees 14,000 crores are allocated for R&D technology development and infrastructure. Just imagine 14,000 crores the Indian government is giving for R&D development. So it is for the college faculty, you can always apply to these government agencies for the R&D development. FAME India Scheme 2015, promoting hybrid and electrical vehicles adoption, extended till 2024 with 3,311 crores spent supporting 2,66,470 vehicles, sanctioned 6,306 e-buses, 2,807 charging stations approved in 68 cities under phase 2. As I told you, not only electrical vehicles, battery, motors, now we have another thing is charging stations. Even that business is going to increase like anything. You can see this. Aim to enhance the battery infrastructure with a budget of 18,000 crores over 5 years for advanced chemistry, cell battery manufacturing. The batteries are the main cost. 30% of the cost of the vehicle cost is the battery. So now Indian government is almost giving 18,100 crores for the R&D on battery development. EV policy. Now the new thing is in the buzzing is battery swapping policy. Target EV charging infrastructure for metropolitan areas, phase 1, and cities with 5+ lakhs population, phase 2 implementation in span of 1 to 3 years, 2022 to 2025. They are spending almost 1 lakh crores to develop battery swapping systems. Other incentives, tax exemptions up to Indian rupees 1,50,000 on EV loans under sanction from ATEEB, custom duty on nickel ore reduced from 5% to 0%. So that in there is a scope for batteries manufacturing. That's a bigger industry, but a smaller scale battery charging station will be viable for even a student level to start up as an entrepreneur. When you see the EV vehicle, key components are battery. The primary energy source is lithium-ion, solid state, and nickel metal hydride. The electrical motors are also important in the EV sector. Converts electrical engine into mechanical energy to drive the wheels. Charging system include onboard chargers, connectors, and external charging stations. This is also another area where we can tap. Regenerative braking system, recover energy during the braking to recharge the battery. Again, these are major advantages over the conversion engines. Energy management system, optimize power distribution for maximum efficiency and range. What is here? There's a very good trick involved in that energy management. I was involved in one of the company in developing the AI system for the energy management. Suppose when we are a regular driver, you are going to office and come back at so and so time, and you are coming back. The AI will understand the pattern of your driving. Suppose your office timing is 9:30, you started at 9. That means you have 30 minutes time, 30 kilometers. So it will not allow, even though you are trying to go at higher speed, it says you have 30 minutes time, it optimizes and gives the power. Suppose you have 15 minutes time only, and the traffic condition checks that. Based on that, it will allow you to go at a higher speed. This now AI has been introduced in the electrical vehicles also. And also, when you plan the route, suppose I am going from here to, let us say, from Hyderabad, central Hyderabad to 100 kilometers away. So what are the charging station available within this 100 kilometers? What is the battery strategy? It warns you before the battery start to come, please charge your battery is going to low. Charging station is available at so and so end. So that means software engineers are also going to play a vital role, and also communication engineers, ECE people, also going to play a vital role in future electrical vehicles. Batteries are backbone of electrical vehicle, influencing the range, efficiency, and cost. EV batteries are categorized based on the chemistry, performance, and application suitability. When we were working on an initial first stage electrical vehicles, the easiest ways was the back seat totally they are laid with the batteries, right? So then what happened in case of any accident or fire extinction, the total 30% of the vehicle get burnt out because of the batteries. And also electromagnetic radiation is occurring because of the lot of conductors to connect batteries in series and parallel. So now to address that issues, now batteries are overlaid over the entire area of the car. Thereby, the thermal management is taken care. Lithium ion, most common EVs, high energy density and long lifespan. Nickel metal hydride used in hybrid vehicle, better lifespan but lower energy density than lithium ion. Lead acid, low cost, mostly used in auxiliary power, heavy and low energy density. The new thing is solid state battery, emerging technology with high energy density and safety, promises faster charging and longer lifespan. These solid state batteries are in an acid stage, which sometimes they call it as super capacitors and all this thing. The research work is going on. When you compare the EV battery comparison features, the energy density, lithium ion is high, nickel metal hydride is moderate, lead acid is low, solid state battery is very, very high, energy density is very high. Cycle life, lithium ion is long, metal hydride moderate, lead acid is short, and when it comes to solid state, longer than the lithium ion. So when you see the comparison chart, solid state batteries are going to be in all aspects except for the cost is high. Other things are much, much better. But R&D, still these batteries are in R&D stage. They are doing the trials. But now most of the vehicles we use lithium ion only as comparatively to, and that means lithium ion and solid state, we can near about comparison is there. That's why now currently we are using lithium ion. That's why to encourage the government of India to import that ore, lithium ion ore, they are giving a subsidy. Battery related challenges what we face. High cost of EV batteries account for 30 to 40% of the vehicle total cost. Limited energy density affecting drive range and vehicle performance. So every time you have to be guard. Petrol means wherever I go, I can fill the petrol and keep going. Whereas the battery vehicles, you have to charge. You need to have a charging station, and it takes time to charge also. These are the slight challenges are there. Battery degradation over time, reduce the capacity and efficiency. First year it was I am able to run for 120 kilometers. Second year maybe 100. Then third year maybe these things. And these are the challenges people are addressing on these issues also. Thermal management during the charging, essential to prevent overheating and ensure safety. Very often we hear a news that battery vehicle got burnt out. This is mainly because of thermal management during the charging. These issues also have been sorted out. People are working on the issues. Conclusion: lithium ion dominates the EV market due to its balance of performance and cost. Solid state batteries are future, offering improvement in safety, energy density, and efficiency. The choice of battery depends on EV design, cost, consideration, and intent to use. Suppose I am a rare user. I just want to go to office and come back. That means I am a rare user. So then you can select it. Now the future cars, I can select my battery. I said I'm not going to use much, only to office and come. I use a different battery. That means your car cost come down. No, I'm a very vivid user, so I want the best battery. Then your same car model, the cost goes up. Energy efficient. Then after battery, the next thing is the motors. Motor plays a vital role in electrical vehicles, right? And here the power consumption is equally important. The energy from the electrical battery to the output, it should be highest. Then only you get the better efficiency. The electrical motor is the most important part of the electrical drive and the last link in the chain of energy conversion. DC motors, because of their good qualities, control of the rotation speed and control of the torque, for a long time have been irreplaceable part of the control electrical motor drives. Advancement in the control techniques have enabled asynchronous motor, also known as induction motor, to replace DC motor in many related drives. Asynchronous motors are increasingly favored due to their reliable performance, robustness, and cost effectiveness. Now, most of the vehicles, they have been replaced with these asynchronous motors. We'll just get into little details of DC motors. DC series motors excel in electrical vehicle due to their high starting torque, efficient energy usage, and simple speed control through voltage regulation. DC motors are very simple to do. Compatible with the regenerative braking and adaptable to the varying load enhances the efficiency and reliability in EV applications. The advantage is that I don't have a load, it draws less current. I have full 4 people are sitting in the car, it draws more current. This is possible with DC motors, DC series motor. The next best was brushless DC motors. Most of the two-wheelers, scooters are uses the brushless DC motor. Brushless DC motors, unlike a traditional DC motors, lack brushes, resulting in a simpler, more compact design with better heat management and operational efficiency, energy saving due to lower mechanical losses. It has several advantages over the DC motor. High torque density, quieter operation, longer lifespan. These motors are ideal for electrical vehicles and applications require low noise. Then it comes to now we are shifted to three-phase AC induction motors. Offers high torque control and energy efficiency, making them ideal for precise power output and energy conservation. However, they have limited speed variation and higher cost and may face a regulatory compliances issue. It has its own problem because these motors, when they are installed, we had an induction problem, heating thermal management. So that's why these motors, not many are used. The new generation motors are permanent magnet synchronous motors, offer high efficiency and power density, require less current than the induction motor for the same torque or speed. Provide superior torque control via variable frequency drives and flexible in configuration such as single phase or three-phase designs and making them ideal for electrical vehicles. After experiencing the 1, 2, 3, 4 type of motor, now finally for the electrical vehicles of higher capacity, that means four-wheelers plus the cars and the higher end cars plus the buses, we use most of the time switch reluctance motors, and they offer precise torque control by leveraging the reluctance of the variation in the rotor as it aligns with the stator energies poles. Their robust design eliminates the need for permanent magnet or brushes, reducing the maintenance. SRMs are high efficient with low heat dissipation and noise, making them ideal for application requiring variable speed, high torque density such as electrical vehicles. However, their operation demands advanced control algorithm and precise electronic to minimize the torque ripple and achieve optimal performance. If you see any of the electrical buses, how smoothly they go, wherever they want to stop, just stops and it just picks up like anything. There we use the switch reluctance motor. The basic idea is if you take a 3 kilowatt motor with the permanent magnet, the weight is 1:2. The half the weight we can get switch reluctance motor. Only thing is little bit more electronics required to control these motors. Otherwise, this has a better efficiency. People are working on this also to have a built-in electronic control system within the motor. Now the new techniques have come. The all car people, they said, why I need a very big one motor? Why not I have a for a four-wheel drive 4 motor? Yes, now the high-end cars, they are coming with the that is called package density within the car. Suppose if you put a larger motor, the front like engine, it occupies more space. So instead of that, and from there they have to give a drive to the each wheel. So now they said the motors are mounted directly onto the wheel. Independent wheel control. Each motor powers one wheel independently, enhancing the precision. Torque vector enable better handling, agility, and stability in all terrains. Improved traction, ideal for off-road conditions and slippery surfaces. Enhanced performance, provide higher acceleration speed compared to single or dual motor system. There are some EVs come with the dual motor system, front wheel drive and back wheel drive, some left and right wheel drive also. Now the new concept is the EV vehicles are 4 wheels, 4 drives. Energy efficiency allows for optimized power distribution, improved battery usage. Advanced application like hypercars, luxury cars, and specialized or off-road EVs, where they are using the 4-wheel drives, independent drives. Comparison of electrical motors and types. You can see When it comes to torque, the DC motor got a high start and it drops later on. BLDC has a constant. PMS motors high, torque is high and constant, moderate and drops, high and variable. High and variable is the SRM motors. So when you see the comparison thing, the BLDC stand good for two-wheelers and three-wheelers. SRM motor and AC motor stand for the higher e-buses and all these things. Now we said battery and the motors we got it. Finally, from battery to the motor, there's a converters and controllers. When I say I have a DC battery but AC motor, that means I have to use a converter. I have to have a different speed, then I need to have a controller. That's why I said electronic engineers have a very good job opportunity in electrical vehicles. We have a motor controller, regulate motor speed, torque, direction. Types include vector and scalar controllers. Now, since the batteries are there, battery management system monitor and safeguard battery health, optimize the charging, discharging, and thermal management, where we are going to use the battery management system. Vehicle control unit, central control coordinates all EV electronics, ensure performance optimization and energy efficiency. Suppose you have a battery vehicle and you have switched on the air conditioner. Now the battery is getting low. Automatically, the air conditioner it reduces the pulsed air conditioning mode. These all things are possible with the vehicle control unit. Advanced converters and control enhance EV functionality and efficiency. Innovations in power electronics are driving the future of the sustainable EV technology. There is a lot of research going on to develop the power electronics for the EV sector. Types of converters used in the electrical vehicles. Converters and controllers are the key components in EV powertrains, managing energy flow and motor operation efficiently. They significantly impact vehicle performance, energy efficiency, and overall reliability. DC to DC converters, we use a DC converter also, adjust voltage level for the auxiliary system, lights and infotainment. Step down or step up for the configurations. AC to DC converter, convert grid AC power to DC for battery charging used in onboard and fast charging systems. DC to AC inverter, convert DC power to AC for the motor drive, essential for a vehicle with AC motors. So that means electrical vehicles has a lot of not only battery, the motor also that means the base, the structure is at 25%, then 30% the battery, and 20% is your motor, 10 to 15% is your control electronics. We are going to have a electronic EV supply equipments also now. EVSC is a fundamental unit of EV charging infrastructure. Now we have got a battery, we have got a car, we have got a control system. Now finally batteries need to be charged. So what are the advantages? We'll see. EVS is a fundamental unit of EV charging infrastructure. Power supply and charging. EVSC accesses power from the local electricity grid, a control system and wired connection to safeguard charge electronic vehicles. Okay. Functions of the EVSC control system. Users authentication. Verify the identity of the user. Suppose I develop my own vehicle, I go to some charging station and try to charge, it will not allow. That's why verifies the user identity of the user. Authorizing for charging, grant permission to begin charging the process. Okay. Information recorded, logs charging details for operation and analytic purposes. Mind you, this information is stored in your car as well as the charging station. Network management enables communication and coordination within the charging network. That means, suppose we are in Hyderabad city, there are hundreds of chargers. How do I know? So I am traveling from one area to other area. Each station has four car capacity. Now I assume that next station is this, but already the 4 vehicles are there. This network management will guide you that the next station already 4 vehicles are there. Better you go back or take the next station. Then data privacy and security. Protect sensitive user and network data also. This is also equally important because all the information is like for authentication we will give Aadhaar card. So it should not somebody should not steal that data also. Okay. So that's why I said electrical, mechanical, electronic and IT people also plays a vital role in these EV vehicles. Typical battery specification for different EV segment. Yeah, that means two-wheeler, three-wheeler, first generation car, second generation. Battery capacity is between, for a two-wheeler, 1.2 to 3.3 kilowatt. Generally, we use 48 to 72 volts. For three-wheeler, 3 to 6.8 kilowatt. There they use 48 to 60 volts. What is the difference? Why they use 48 to 70 for smaller vehicle, but the large three-wheeler 48 to 60 volt. Here, 48 to 70 volt, the wattage is very less. But when it comes to the three-wheelers, space constraint is there. That's the reason they want to use the lesser voltage, that means less number of battery module, but higher capacity. That's why they use 48 to 60 volt. Then the cars, first generation car, they were using 72 volts. Now the second generation car, they use 350 to 500 volts. Imagine that why they are using that high volt. Here the idea is higher the current, lower the currents. Higher the voltage, lower the currents. So thereby the conductors laying will be minimal, and heating in the conductors, current heats up the conductors. Lesser the conductor, less heats involved while charging or discharging. Thereby, safety point of view, almost all the e-cars now they are configuring to higher voltages. EV charging required depends on the specification of the EV batteries, as power must be supplied to the battery at the right voltage and current level to permit charging. So now we said charging is okay. Now charging infraction, we have got a typical challenges here again. Internationally, there are some specification. Level 1 charging, it is called. That means utilizes a standard household outlet, 230 volts, and provide the storage charging rate suitable for overnight charging. That means I go to my office, I come back and put it in wherever I park the vehicle, I charge. Level 2 charging require dedicated tool outlet offering fast charging timings, commonly used in the homes and public areas. That means apartment type. Okay. DC fast charging provide the rapid charging using high voltage direct current to the battery, significantly reducing the charging time. Ideal for long distance travel. DCFC can charge an EV battery to 80% in 20 to 60 minutes. Here you'll find 3 orange color and 3 green color charges. The major obstacle now we are facing are first, there are 3 types of charges, 3 types of charging ports. Second time, the fast charging, there are again 3 ports. That means till now we have not standardized the battery charging connectors. Every company has given. Now at least we have 6 different connectors. Now people are working to standardize per single charging connector. R&D is going on. The charging modes, as I told you, 1, 2, 3, 4 charging modes to 4 modes are available. Modes 1 and 2 AC charging modes, they are called dumb charging. Connect an EV to a standard socket with no communication between EV and EVSC, and it is not recommended. That means how charging means, sometimes that's the reason the fire accident occurred, because you just put on the charger, what is happening we don't know. There is no communication that it should stop charging, not to charge, excess charge the battery. Mode 2 use a portable cable with inbuilt protection and control, typically for home charging. Right? 3 and 4 called advanced charging systems. They provide separate charger device with enhanced controls for the commercial or public charging system. That means whenever you want, there is a separate unit they will give that you have to install wherever you want to charge. That is mode 4 is offer the high power charging with improved control system suitable for public and commercial use. See, as you go inside, deeper inside, there are a lot of techniques involved in EV vehicles also. Then public versus private charging. What are the key challenges? The major is standardized issue. As you can see the thing, there are at least 6 types of connectors are available. Now, how do I charge? Infrastructure aspect. Public chargers, private, limited stations in key areas, parking and space constraints, cost, high setup, installation expenses, accessibility, interoperability and standards issues, restricted to owner locations, policy support, lengthy regulation process, multi-tenant property barriers. Suppose you want to put in your apartment, immediately the other people will say, no, 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 you are using unnecessary vehicles, you are parking. These issues are there. The major issues, interoperability issues and public EV charging. Fragmented ecosystem. Multiple operate with proprietary network, restrict access. One charger says you can only charge Tata vehicle, another fellow says you can charge Maruti vehicle. These problems are there. Lack of standardization, variation in connector, CCS, CHAdeMO, Bharat ACDC, limit cross-band compatibility. Now, this charging station only can charge this with this connector, then it will become difficult. Payment incompatibility, diverse payment method and billing format create confusion. So whenever you want to charge, you have to pay. So each one has their own system. No unified platform, absence of centralized app for locating, booking and paying for charging station. These are some challenges. Hardware limitations, chargers often support specific brand only, reduce flexibility. User inconvenient and reduced confidence in public charging network, underutilized infrastructure due to compatibility barriers, slower EV adoption due to perceived lack of reliability. If you happen to move around city hyper station, there are several charging stations are there. They are idle. Because one station says you can charge this vehicle only. I cannot charge any other. And the payment method, as I told you, these are all other limitations are there. Now, India is working out with now they have released one document for a standardization of the EV charging stations. Internally, whatever you use it, finally, when it comes to output, these are the system you have to follow for payment methods or communication method also. Once that is installed, then as you are traveling, as I told you, one charging station is full, it will immediately say, no, sorry, we cannot charge. Next station, it give nearest charging station also, it can communicate and give you. Now the new system is battery swapping. Recharge method is receiving a global attention is battery swap, in which depleted EV battery is removed from the vehicle and replaced with the fully charged one. Here there are issues. Suppose I have a vehicle for 5 years, somebody's vehicle is just new. So how do they, when I replace the battery, am I going to get the new battery or older battery? These issues are there, for which government India also, they all internationally, they are coming out with a new solution. The technology is being tried out on various EV segments, including two-wheelers and three-wheelers, e-cars, even in buses. Instead of charging, you can replace the batteries. Battery swapping, manually battery swapping station, standalone modular device where batteries are manually placed and removed. Compact and safe, efficient, ideal for two and three wheelers application due to smarter, lightweight batteries pack managed by 1 or 2 persons. Autonomous batteries swapping station use robotic arm for semi-fully automated swapping, suited for four-wheelers and e-buses with larger, heavier batteries, more expensive and require more land than manual station. Here, what they are doing, the companies are coming forward that they will take care. Suppose instead of you buying a battery, I said battery services. I said you are not going to bother whether your battery is 4 years or 3 years old. He said we are going to provide 1 year of battery services, irrespective of whatever it may be. Whenever you are giving a battery swapping, that is my responsibility. Whether I am giving a 3 months old battery or 6 months old battery, my responsibility is that for 1 year, I'll give a battery life. This is a new business area focusing by the many EV vendors. Charging issues, limited availability. The scarcity of charging stations, especially in rural areas, poses a significant barrier to EV adoption. Central cities after no problem. I'm going to my hometown. If I don't find the battery station, it's a really headache. Long charging time, a majority inconvenience for users compared to refilling gasoline vehicles. Compatibility and standardization challenges, different connector types and challenges, charging protocols are being used. Cost of installation maintenance, initial high investment for both individuals and government. Cost of installation of the charging station is very high. Grid impact. Widespread EV charging can strain the electrical grid, necessitating upgrading and smart grid solution. Now we come with the new problem. Suppose I have an apartment, 20 EV cars are there. Everybody comes after the office hours, everybody want to charge. Then that means there is a demand for power. So these issues are newly cropping up that also been addressed by the government of India. Now we also have another charging speed and impact on the energy efficiency. Slow versus fast charging. Slow charging is less stressful on batteries but time consuming. Fast charging is convenient but can reduce battery lifespan. There are two issues with the battery. If you charge fast, there is another problem. If you charge slow, there is another problem. Impact on fast charging and battery life. Very frequent charging may accelerate degradation. Suppose I have charged, no, I'm going long way, I want to charge. If you keep on charging also, it will degrade. Role of bidirectional charging allows you to supply energy back to the grid or home. This is a very challenging, very interesting thing. Suppose I'm going out of station for 1 week. If I keep my batteries charged for 1 week, there is a likelihood of fire due to various reasons. Active thing. So what I can do, I can discharge my battery to the grid also. That means I am like a solar panel I have. I'm not using, I have excess power. I can give the grid. Whenever I want, I can take it from the grid also. Now the bidirectional charging station also have come. Suppose I have 2 cars, 2 people are going. I have full charge, my cousin does not have charge. I can pass on to grid and pass to him also. Even that is the new techniques are coming in. Future advancement, ultra-fast charging technology promise full charges in 10 minutes. Now, the new techniques for the battery is, it has to charge within, just put in like a petrol. I go to a petrol pump, fill and get out. So similarly, these kind of things also underway. Now, you said electrical vehicle, everything you have done. Now, new challenges are grid challenge due to EV charging. He says, increased load on the power grid, rising EV adoption strains electrical supply, peak demand management, simultaneous charging during the peak hours and cars outages, regional power shortages, insufficient infrastructure in certain areas, role of renewable energy, solar and wind energy integration to balance the grid loads. Delhi notified its EV policy in 2020 with ambitious target of electrical vehicle reaching nearly 5% of new vehicle registration in 2024. The policy focused on electrification of the shared and commercial transport. The policy is also a key measure to tackle the city deteriorating air quality. So that means we have sorted out the air pollution, but now new challenges are that how do we provide power to charging stations? These are new issues. Potential solution for the charging solution. Public charging solution. Streamline government approved and incentivize investment. Promote public-private partnership for network expansion. Introduce roaming agreement for interoperability. That means charging station also can move around. Private charging solution. Mandate EV-ready infrastructure in new residential and commercial buildings. Offer subsidized or taxes breaks for home charger installation. Educate consumer about home charging benefit. Like rain harvesting, future whenever you build a building, they will say you have to compulsory mandate that UV ready infrastructure to be provided. Grid support, develop a smart grid technology to manage peak loads, develop renewable energy integration for EV charging. Now that to avoid the demand and the grid, they said better to use the renewable energy resources. Solution to the charging issue. What is the solution now? Advancements in the battery technology. The new batteries are coming in the way. Trials are on the way. Solid-state batteries offer high energy density and faster charging time compared to the traditional lithium-ion batteries. Ultra-fast charging batteries. Research is going on into the batteries that can charge 80% of the capacity in minutes without compromising longevity. That's the reason, as I told you, high voltage, low current. When the batteries are high voltage, low current, that means I can quickly charge the batteries. When the current is the current equal to time, higher current, higher time. So that's why people are going for the higher voltage and lower current. That's why I can instantly charge my batteries. Smart charging system. Implement smart charging system can optimize energy consumption by adjusting charging time based on the grid demand and energy prices. Here once again what they do is, suppose peak demand time, summertime everybody switches on the ACs. At the time you want to, from the charging outlet you want to charge, then they may charge slightly more. Renewable energy integration. Utilizing the solar or wind energy for charging station can reduce the carbon footprint and elevate grid stress. Now, as you will do, number of electrical vehicle increases, definitely the demand for the electricity also going to be more. Now, for that, the alternate solutions are whether you should have a solar systems or wind energy. Technical solution for charging issues are expansion of charging networks, establish more public charging stations with high-speed DC chargers to enhance the accessibility and reduce the waiting time. If they have more charging stations, it is easy. But you said more, then what is the problem? Wireless dynamic charging system. Develop inductive charging pad for the stationary vehicle and dynamic charging lanes for charging vehicles in motion, improving the convenience and range. Now, the new system is this, wireless, no more connector. You just vehicle moves around, it charges. Battery swapping technology, implement modular battery swapping station to enable quick and standard battery replacement, reducing downtime for users. Now people are thinking different out of the way. See, smart grid integration, vehicle to grid system. Use a V2G technology to optimize electrical city usage, stabilize the grid, and support renewable energy storage. Proper battery management can mitigate concerns about reducing the lifespan of the due to V2G usage. What is a smart grid integration? Now, many countries like trams, they have electrical wire running out. Like a metro, we have a electrical wire running around. So that means as your vehicle moves, you can connect your vehicle to the grid and charge also. And also if you have excess power, you can supply to the grid also. This is also, the research is going on the way. Key distinctions of EV charging as a consumer. Consumer, what is the problem we get? Mobility of electricity requirement. EVs are mobile, making energy requirement and power demand at charging points unpredictable during initial phases. We don't know, people suddenly there's a Kumbh Mela. Yeah, all vehicles are going towards the Kumbh Mela, then everybody want to charge their vehicles. That means because of the electrical, the vehicles are moving, the electrical demand will keep on moving. Intermediate charging load. EV charging demand is characterized by spikes, potentially impacting the local distribution network, especially in area with limited hosting capacity. Bidirectional energy flow. EVs can act as a prosumer by feeding electricity back into the grid through a vehicle-to-grid functionality, serving as a potential distributed energy source. EVs can also do that whenever you have excess thing. You can also, when based on the demand, it makes the request. You have a 100% charge station. Can I withdraw from you some energy? That means the EV vehicle also can give the same when you are in the stationary mode. Future trends in EV charging. Inductive wireless charging eliminates need for physical connector. Solar powered charge station combines renewable energy with EV infrastructure. Use of blockchain enhance the security, transparency in payment, and authentication process. Autonomous mobile charging route, bringing charging to vehicle instead of fixed station. That means big batteries will charge, the vehicles will move, and that means that your vehicle stop due to charge. The vehicle come with the battery, maybe a generator inside that will charge the system, your electrical vehicles. Environmental impact of EV charging depends on the fossil fuel. Many grids still rely on non-renewable resources. That is again a problem. Potentials of the renewable energy, solar, wind, hydro can minimize these emissions. Recycling and disposable, safe and efficient recycling of batteries to reduce environmental harm. This is also equally important because people use for 5 years, after they throw the battery wherever they want. Then what do we do with them? Life cycle analysis, evaluate the total environmental impact EVs and charging infrastructure. Research are going, what are things, now new types of batteries have come. Now what happened to the old charging station batteries? This also, they are working on that area. Smart EV charging important. Cost efficiency, automatically adjust charging rates and schedule based on the real-time power prices and availability, reducing the cost and improving energy efficiency. Sometimes, as I told you, the power demand some areas sometimes are more. Based on that, it also get adjusted. The charging time, charging rates, and the cost also. Thereby, you can increase the energy efficiency. Sustainability, integrate with the renewable energy sources like solar, wind for cleaner, sustainable charging. Again, here they said internet connectivity, provide real-time updates on charging status and availability, helping driver to plan their trips and charge need effectively. As I told you, communication people also equally required for EV vehicle infrastructure. A reduction of losses in the conductor and connectors. Now we have gone through all the things. Finally, conductors also, electrical vehicle conductor plays a vital role. That's the reason people, when I say I'm working on 40 volts, 100 amps, thick conductors are required. When I'm working on 400 volts, 10 amps, thin conductors are required. Conductors and also the connecting ports and the wires. All those things are also plays a vital role. Reduction losses in the conductors and connectors. Energy efficiency is in conductors and connectors. Supply voltage and quality contacts in connectors and cables are critical for reducing energy losses. Design optimization must balance constraints like safety, space, and cost. Because as I told you, if you keep on increasing the higher voltage also, once again, you have to see the safety aspects also. Battery safety in EVs. Battery fires have led automakers to recommend discharging the lithium batteries after serious crashes. Completely discharge can permanently damage the battery and render it unsuitable.
Any problem? Participants?
Lot of matter on the net.
Can I continue?
Yes, sir, proceed, sir.
Continue?
Yes, sir, yes, sir, continue, sir.
Self-discharge and parasitic load from battery management system can be also irreversibly drain the battery.
Participants, everybody mute your microphone, please. Okay, sir. Thank you, sir.
See, batteries, as I told you, if you're not using your vehicle for a long time, he says that the management says, please discharge the battery.
Participant, if you have any query, you can.
Yeah, later on I will definitely answer them.
Yes, sir. Yes.
Energy management system EV, role of artificial intelligence, predict energy needs and optimize the usages, predictive maintenance, monitors battery health to prevent failures, monitoring and controlling energy flows, ensures the efficient operation and minimize the waste. Integration with renewable energy helps to reduce dependency on fossil fuels for charging. What is that integrated with renewable energy? Now car owners also coming with is semiconductor device, that is floral rooftops. It may not charge 100%, 10 to 15%, at least infotainment systems can handle directly with the solar panel mounted on the rooftops of the car. Now, the car load, lightweight material, advanced lightweight material, reduce the vehicle weight. This results in lower energy consumption and extended driving range. These are the areas the people are working on that. Now, the major advantages of EV vehicles are regenerative braking. Energy harvesting mechanism converts vehicle motion energy into electrical energy instead of wasting it as a heat, unlike traditional mechanical braking. Electrical motor functionality operates as a generator during the braking to absorb kinetic energy and recharge the battery. This advantage we have with the EV vehicles. Integration with EVs designed for all electrical vehicle without the need for additional component, ensuring the streamlined system. Battery, the recharging process during the regenerative brake does not increase the battery degradation, even at low temperatures such as that. Now we issued so many issues. Now they said electrical vehicles, movable aerodynamics thesis. Some aerodynamic, if you can adopt, still the efficiency can increase. Functionality, movable aerodynamic component like wings, flaps, and ailerons adjust to improve the stability performance commonly seen in aircraft such as airliners and fighter jets. He says body also, if you can modify, it will increase the efficiency. Operational mechanism. This system utilizes hydraulic tube, rods, and actuators to control movements and positioning. Space constraint. Formula One car integrates similar systems in highly compact spaces, highlighting the innovative design for efficiency. Application EVs, electric vehicle can adopt those technologies to ensure enhanced aerodynamics, leading to the improved energy efficiency and performance. Normal, the IC engines front compartment required such big space, whereas this required less space. So that means these vehicles have to redesign to contour that minimum space requirement. That's it. Aerodynamically, it can balance and reduce the energy consumption and load on the batteries. Lighting and heating of the EV vehicles. The rapid advance in high-intensity LED technology has led to the substantial reduction in energy consumption, crucial for electrical vehicles. Instead of halogen lamps, you can use the electrical EV LED lamps. Thereby, you can reduce the consumption load on the batteries. And all LED systems using the current generation of LEDs in exterior vehicle lighting design can achieve power saving. Approximately 50% saving during the nighttime operation, up to 70% saving during the daytime operation. That means based on the daylight operation, red light indicators, headlights, automatically based on the external, the ambient, it will change the settings. These savings contribute to the improving energy efficiency and extended driving range for EVs, reducing the battery load and supporting sustainability. That means every component plays a vital role in electrical vehicles. Reducing loss in the conductors and connectors. Even the connector plays a vital role. Ensuring the energy efficiency requires careful selection of supply voltage, high quality contacts, and connectors for cables. Optimization of supply voltage. The choice of supply voltage should minimize the losses while staying within the design constraint, battery overvoltage safety, limited space, and cost consideration. What voltage select? These are the consideration concerned. Conductor selection optimization. The cross-section selection of the area of the conductor should be optimized to reduce energy losses while considering the space limitation and cost factor. Connector selection. Just as with the conductor, selecting the connector that provide low resistance, reliable contact is crucial for minimizing the losses and ensuring the efficient energy transmissions. Then everything comes, then people say, I have bought this vehicle, it should also give me a comforts also and safety. Advanced climate control system ensure passenger comfort with minimum energy usage. Normally in our regular cars, we just switch on the AC, it just keeps on running. The EV cars, it can pulse mode. That means air condition will not be on continuously. few seconds on, few seconds off, few seconds on, few seconds off. That means you get illusionary feeling of comfort, but not exactly totally cooling. Similarly, infotainment system, energy efficient displays, processors provide seamless entertainment and information, like front panels and all this thing. Safety features, active system like collision avoidance and lane keeping uses low power sensor to ensure safety also. Seat climate control, energy efficient heating and cooling for individual passenger comforts also can be possible with this electrical vehicle. Navigation for safety, route optimization aid in efficient travel and hazard avoidance. Integrated system, intelligent power distribution ensures the balance between comfort, safety, and information needs. Now, the trend is hybrid vehicles. Why? Hybrid vehicle combine technologies for energy production and storage, having gained global interest for their low fuel consumption and reduced emissions. They are cast into parallel and serial hybrids. Parallel hybrids have a mechanical link between the power generation and drive wheels. In contrast, serial hybrids lack such connection, offering a mechanical simplicity, design, flexibility, and easier integration in new generation. That means parallel means the system is parallelly combined. The clutch mechanism will delink or link. Whereas serial means whenever you want, you declutch the combustion engine and connect with the wherever it is required. It supports with the battery systems. Policy and incentives. Government initiative, subsidies, tax credit, and rebate to encourage EV adoption. Subsidies for installing charging station, finance support for business and homeowners. International standards and protocols ensure compatibility to ease out CCS, CGO, and CBIT connectors. Focus on sustainability, energy sourcing, policies to promote renewable energy for EV charging. These are the government instructions to enhance the facilities. So with this, I conclude my presentation because I made it very short so that I will not take the time lapse. So any questions I can answer now.
Thank you, sir. Thank you very much, dear faculty. You can clarify doubts. You can take the sir contacts also, mobile number as well as
Anytime.
my ladies.
Sir,
Sir,
this is Dr. Anil Kumar.
sir, question, sir.
Yeah,
Sir, this is Dr. Anil Kumar from School of Renewable Energy and Environment,
okay,
JNTUK, Kakinada. Here I would like to know if I want to set up how to plan a renewable energy based captive power generation for EV charging.
Yeah, the government of India, of India has a plan. In fact, I will share a document, the latest document they have given. I will share the document in that all the issues related to this has been mentioned.
Thank you, sir. One more thing, sir.
Yeah.
And now you have mentioned about related to international standards, CHAdeMO and GB/T and CCS.
Yeah.
What are the major differences between these three standards and which one is most applicable under Indian scenario?
Yeah, the problem what happened, we have got three type of vehicles and batteries.
Yes,
now
sir.
we cannot shift. That's why what they are using, all the chargers have a three type of modes.
Yes.
It can charge slow charging, it can charge also fast charging, and voltage also.
Okay.
Because variable voltage, variable current, the charger cost is going to go very high.
Okay.
But at current status, the new vehicles, they are coming with high voltage only. Okay. So no issues. But we also have older vehicles. Now the car manufacturer, they cannot take away the old vehicle and give you a new one. So for another 10 years, they have to maintain that charger number 1, charger number 2, charger number 3, and charger number 4 also. But new vehicles, new stations, people are going for the fast charging mode only. Because why they call fast charging here, it's a little trick involved. They made voltage high, current low. Let us say 400 volts, 1 amp, 400 watts.
Okay.
So 1 amp charging take 1 hour, let us say. Rather 40 volts, 10 amps take 10 hours.
Okay.
right? So they say fast charging means higher voltage, low current.
Okay.
So that's how they're managing the batteries there.
Yeah. Is there any Indian that has standard that has been specifically
Yeah,
mentioned?
I have a document I will share with the sir.
Okay. Sir.
Mr. Dilip Gar, Dr. Dilip, he will share with you.
Yes, sir.
Thank you.
Yes, sir. Definitely, sir.
Sir, good afternoon, sir.
Good afternoon.
One more doubt, sir.
This is Professor G. Nagamalleshwar Rao, sir, speaking from Narsarapeta.
Yes, sir.
Sir, definitely you have mentioned that there are certain charging issues, right, and etc. And research is also going on regarding charging issue as well batteries. Sir, I would like to mention this here, the powertrain problems also, like thermal management issues.
Yes.
Thermal management issue also to be considered, sir, because of this is reducing the battery life as well as there is some fire accidents also taking place.
Yeah.
So that how efficiently we can manage this thermal issues, sir.
Yeah, what they did is initially the car they used to have lower voltage and higher currents. Whenever the conductor size is more, current generates heat. So what they did is to avoid this, the cluster to connect the batteries in series. I don't have to use now. Previously, batteries are connected. Each battery is a lithium ion is 3.2 volt. Maximum 3 amps will be there. So now to make it into 100 amps like that, series parallel combination were used. Now 400 volts battery means 100 batteries in series. That means the conductor in between battery is minimized, and the current flowing through the charger now is only a few amps. Thereby, this thermal management they could reduce. And what they did is initially when the EV vehicles came, most of the time the batteries they were in the back seat, right?
Yes, sir.
So,
Yes.
the combustion engine to put the gearbox used to occupy the more space. Now, in between the seat, we have a space. So now, what they do to avoid this thermal management and recycling, and also to avoid the water entering into these batteries, they layered over the total cabinet area. Front, anyhow, we cannot change the total front like combustion engine. We cannot take away, make it flat. So what they are using the front area to the back area. Thereby, the boot space is also given for the people to carry things, but they are using the maximum floor area till the combustion engine. Thereby, they have answered the thermal the problems in the new vehicles.
Sir, one more thing, sir.
Yeah.
Yeah, sir. Highly populated countries like India, right? How the public charging stations work, sir?
Here you have to pay and use it. It is like, authentication, what they call it. Like, I go to a shop and scan the QR code and then buy things.
Okay, sir. Highly densely, what we can say that they are very highly populated, isn't it, sir? Because I saw in the European country that they are doing just what they are following the same.
Yeah, but I understand this. That's why now government India requesting, see, like Hyderabad, hundreds of apartments are there, and definitely parking space is available. They say at least this area, future all new apartment, they should provide the charging station. Now government of India is giving incentives individually. Those who want to install the charging station, they are permitting.
Yes, sir. Yes, sir. Okay, sir. Yeah.
Thank you.
Thank you, sir. Thank you, sir. Thank you very much.
Any more questions, please?
Faculty, do you have any other questions, please? Sir, sir, one more question, sir. Please.
Please, ask, please.
Sir, what is the future perspectives of this charging stations? in
If
India, especially in remote places, sir?
If I am right, and in fact, last 1 week I was going through all the documents from the national and international bodies.
Yes, sir.
In fact, somehow I feel lecturers plays a vital role to encourage the entrepreneurship into students.
Yes,
They
sir.
can get the subsidy from the government to install the charging station even in rural areas. Rural areas, almost 90% subsidy you get. If you
Okay, sir.
because grid connectivity is a government problem. Government is taking care by giving a power up to your charging station, and the charging equipment almost 90% they are giving a subsidy.
Okay, sir. Sir, is there any procedural steps that one should follow to apply
That's
for?
why I told you I have one document. I will
Okay.
follow it. Please follow forward to all the participants.
Will it be open to
Yes, yes,
every
open.
throughout the year, sir?
The policy document they have given, in that
Okay.
every most of thing has been mentioned very clearly, and the BJP government, central government now, they are willing to give any amount. As I told you, almost 1 lakh crores they are spending on charging stations.
Okay, sir.
So at the college, what we have to do is entrepreneur skill. They say we would like to adopt a village and we want to install some 20 stations and take forward that. That may be easier. As an individual, maybe going through maybe a little difficult, but right as of now. But as a college, selecting one village, okay, this whole village we are going to install some 20 stations. That become very easy.
So, do the applicant need to satisfy any other qualifications?
No, not very big thing. Yeah, if so long you are an engineer, you can do. In fact, they are not also asking for engineer. So long you can understand what is electricity, what you can do, you have a proper bank account, you are credit, they will ask basic question whether you are going to just take the subsidy and running away, or they don't give directly any money to you. They will, when you buy a charging station, they give all the money to them only. So we have
So,
that
during
advantage.
the application, do the applicant need to pay the fees
No,
or
very nominal, very nominal. They are just throw away.
any commitment?
Very, very less actually. Land
Okay.
you have to show. Some small land where you are going to secured land, what we call it as. You cannot say on the top of somebody's building I'll put.
Yes,
So
sir.
that land have to be secured.
Okay.
Then they will allow. Even they are giving permission. Suppose municipal corporation footpaths are there. They said you can put there, but it is your responsibility to maintain.
Yes, sir.
Yeah, that much they ask you, because you just put it and you collect money. You don't even bother to look into it. That they don't allow. You said you take a responsibility, and we'll allow you to put it on the footpath where the vehicle can be parked, not on the main road. You will say, okay, I put a station wherever possible areas, like a small park where one car can be parked. Yes, you can go ahead. That's the thing up there. Yes.
Okay, sir.
Since we have a little more time, I will take it.
Yeah, that's the time. Almost you have come to the same time, sir. But any faculty would like to clarify doubts regarding the government policies and the prospectuses in the charging stations in remote places like our villages. So, sir said to forward the policy. We will definitely share among this group.
Yes.
You can go through it and you get benefit out of it. Arrange some charging stations even in the remote places also.
Yeah.
So thank you, sir. Thank you very much.
Thank you all for giving a precious time, and I wish all you are successful.
Thank you, sir. Thank you very much. Thanks. So, dear part.
Sir, Dilip sir, mute lo పెట్టారు sir.
Session 1 is concluded. Session 2, guest also, speaker is also ready. We thank our session 1 speaker with his experience. We could expose it to industrial and government policies of these charging stations. Thank you, sir. Thank you very much.
Sir, again it is muted, sir. Dilip, sir.
1 minute, 1 minute.
Now it is okay, sir.
Yeah.